All right, so it's recording right now. So for the first problem, we have limit of x approaches to -2, and then the plus sign. That means we will look at x equal -2 first. So x equal -2 is right here. This is -2 on the graph. And since it's a plus sign, therefore we only look at the right side, okay, of the function. So we will find out when you approaches -2 from the right side. Okay, from the function you approaches to -2 from the right side. What is the limit, or what is the y value that you when you approaches to x equal -2? What's the y value? Okay, I have, okay, say -1. All right, that's correct. So it's -1. So here, this point right here, if you try to match it with the y-axis, so the y value will be -1. So yes, this is -1. Okay, does it help you remember a little bit more about limit when we went over limit last week? Hopefully it helps you a little bit. And we move on next part. So we're working on second part right here, limit, okay, and then x approaches to -2, and this time we have the minus sign in the exponent position. So that means we will look at the x value at -2, but from the left side of the function, okay. So approach it from the left side function, go toward -2. What is the limit? Same thing, -1. Thank you. Okay, so we still get -1. All right, so then next we move on this part right here. So what is limit right at x approaches to -2? Okay, I have D and E, and hopefully you guys know D and E stand for does not exist. Any other idea? I already said -infinity. I didn't say no solution. Not saying it's right or wrong, but for those of you who think whatever you think right now, would you be able to state your reasoning? So what is the reason you think it's no solution, it's -infinity, or even it's -1? What is the reason behind it? I would like to know. I'm curious. Okay, so ivory means does not exist. Okay, it didn't say there's a hole at x equals -2, so that's why he thinks there's no solution. Anyone else? Okay, because it's an open hole, meaning there's not exact point at -2, okay? You think. All right, I appreciate it. Anyone else? No? All right, I'll take this chance to emphasize the difference between limits at a value and the output at x value. Okay, I'll take this as a chance. So if I ask you guys, what is f of -2? So when I have x equal -2, what is my y value? Okay, Trung give me 0. Ariel give me -1. Sasuke give me about -1. But Trung fix it, -1. Anyone else? Don't be afraid to share with me what you think. Guess it's okay too. It doesn't hurt. So if I remind you, okay, at -2 on the function, what do you see? When x equals -2, what do you see on the function, on the graph? An open circle. An open circle means that's the hole right there, right? So if it's an open circle or it's a hole, do we have the y value? No, we don't have it. All right. So if I ask you to evaluate f of -2, the answer will be what? No solution, yes, or undefined, right? Or does not exist. All right. However, when we take limit when x approaches to -2, we still have the value for limit. Limit means it get very close. It may or may not cross the value, but as long it get very close to that value, we take that value at limit. So if I say that, does it change your mind now on limit of x approaches to -2? Any guess? Okay, Sasuke, give me -1. Anyone else? No? Waiting for my answer. Yes, I agree with you, Saskia. So limit will be -1. So you guys see the difference between evaluate the function at x value and find the limit at the x value. So we do this at the same x value, which is x equal -2. But if you evaluate, you will not have the answer for the output. But if you do limit, you do have the answer for the output. Does it make sense? And you find more surprise things today when we get to the end of this problem. The right answer is -1, Trung Anh. Limit of x approaches to -2 is -1. You see the two things different. This thing right here, you evaluate f of -2, or you find the output. Output or y value when the input or x value equals -2. See it? This means you find the limit of the function when x approaches to -2. You see the difference? Okay. I'm glad that you asked question. All right, can we move on next part now? Good question, Lynn. Like I said, your question, let me hold on your question and then let's move to the end of this problem to see if I can answer your question. All right, if you still don't get the answer for your question, please remind me. Okay. All right, so next we move on. Limit of x approaches to 0 on the right side. So then I need to go with this. Okay, so 0 is right here. So if your function approaches to 0 on the right side, okay, on the right side, where's the limit? -1. Anyone else? Thank you, Saskia. Thank you, Ivory. Anyone else? Thank you, Lynn. Yeah, just put it in. Just confirm your answer. Okay, just one way for you to remember it. Thank you, Aiden. Thank you, JC. So yes, it's -1. All right, now next part you will find a limit when x approaches to 0 on the left side. Okay, on the left side, right here on the left side. Where's the limit? Thank you, Saskia. Still -1, right? Okay, thank you guys. And we're doing next part. So then when x approaches to 0, what is the limit when x at 0? Thank you, Lynn. Thank you, Saskia. With question mark. Not confident enough? You should trust yourself. Oh yeah, so it's -1. Before we go further in that, is there anything you notice when you take the limit on both sides and when you take the limit at that point? Is there anything you guys notice? Now I need to know your observation. Is there anything you notice? The limit is just the y value, okay. Anything else? They the same, all right. Okay, so that's good for now, and we can move on to the last part, all right. So now last part, let me erase this first. We're doing this, so limit of x approaches to 2 on the right side. So on the 2 right here, and on the right side, what's that? Where is the limit when x approaches to 2 on the right side? Thank you, Saskia. Thank you, Trung. Thank you, JC. Thank you, Lynn. Hopefully we all get the same thing. Yes, I agree. It's 6. All right, next one on the left side. On the left side. Thank you, Saskia. Thank you, JC. Thank you, Lynn. And you guys put it faster. So I think you're more confident or feel a little bit more comfortable with this one, this concept. Yes, I agree. So limit will be 3. Now, next part. What is limit when x exactly at 2? Just silence. Okay, got 3 with question mark. 3, 3. Okay, unfortunately for this one, when the limit at x equal 2, we don't have limit at x equal 2. So in this case, does not exist. How? Yeah. All right. So because we have limit on the right side is 6, on the left side is 3, they don't agree with each other. So therefore, when we have limit at x on x at 2, we don't have limit. So in order to have limit at the x value, your both sides limit has to agree with each other. Has to be the same, yes. So that's why I asked you guys question earlier. What do you notice from the one side limit from both sides, from the left side, from the right side, and at the end we come up with the same value when we on or at x value. But right now for the third case, we have limit on the right side is different than the limit on the left side. Therefore, when we have the limit at the x value, we don't have limit. Does it make sense? Did I confuse anyone? Okay, time for you to process and ask me question. We still have 1 minute to ask question. I would say yes, Trung An. All right, anything else? Okay, anyone need to take a picture of this problem because I will post this video on Google Classroom for you guys to watch it at your own pace again. For those of you who would like to watch it,